NOAA says the 2026 Atlantic hurricane season likely will be below normal. But that does not mean the tropics are quiet. It means the risk is shifting. El Nino may suppress the Atlantic while raising the caution flag higher across the Pacific and other parts of the global tropics. The Atlantic season runs from June to November, and NOAA released their official 2026 hurricane outlook in May. Below normal, 8 to 14 named storms, 3 to 6 hurricanes, 1 to 3 major hurricanes. That is below average, but not a zero risk. And most of the headlines you've seen this week stopped right there. This video doesn't, because the Atlantic being quiet isn't the same as the global tropical cyclone picture being quiet. The environment favorable for tropical development is just shifting elsewhere, and when you look at what sea surface temperatures are doing across every ocean basin right now, there is a lot of energy. The pattern that suppresses the Atlantic often makes other regions more favorable for hurricane development. This does not guarantee impacts, but it does shift the probabilities. Today we're going to go basin by basin, starting with the Atlantic. What NOAA's forecast actually means and why it's the correct call. The Eastern Pacific, the basin El Nino supercharges, and one we should not ignore, the Western Pacific typhoon season, and the broader global picture, all covered in today's video. If your region isn't in this video, or if you want to go in deeper on any specific basin, drop it in the comments. I'll build around what I'm hearing. So why does El Nino quiet the Atlantic? It comes down to wind shear. When sea surface temperatures warm in the eastern and central equatorial Pacific, the ENSO region, which is increasingly developing right now, it strengthens the upper level winds flowing west to east across the tropical Atlantic. Those winds essentially decapitate, if you will, developing tropical systems. A storm needs a relatively calm, consistent atmosphere from top to bottom to organize and strengthen. When strong upper-level winds are moving in a different direction than the storm below, at the lower levels, in that circulation area, the system falls apart before it can get going. NOAA is calling for 8 to 14 named storms, 3 to 6 hurricanes, and 1 to 3 major hurricanes in the Atlantic Basin. Now, a typical season produces 14 named storms, 7 hurricanes. This forecast is consistent with what the El Nino signal predicts. The Atlantic shear signal is real, but it covers only this basin. There are several others. The Eastern Pacific Basin runs from the Mexican coast out to about 140 degrees west longitude, and El Nino does the opposite to this basin from what it did to the Atlantic. Warm water, less wind shear. The jet stream that suppresses the Atlantic development actively enhances the Eastern Pacific conditions. So in strong El Nino years, the Eastern Pacific becomes one of the most active hurricane basins on the planet. No two El Nino years are identical, but El Nino tilts probabilities strongly in some cases, especially this one. NOAA's forecast probabilities support an above normal Eastern Pacific season. That'd be 15 to 22 named storms, 9 to 14 hurricanes, 5 to 9 major hurricanes. In 2015, kind of the last comparable major El Nino event, 2023 had a different sea surface pattern driving it. So 2015, the Eastern Pacific produced Hurricane Patricia. Patricia briefly reached 215 miles per hour sustained winds offshore, making one of the strongest tropical cyclones ever observed globally. It weakened before making landfall in Mexico, but still struck that coastline as an extremely intense Category 4 hurricane. The Eastern Pacific in El Nino years is not a basin to ignore. Now, most Eastern Pacific storms track westward or northwestward, well away from major population centers. But here's why it matters for viewers in Arizona, New Mexico, southwestern Texas, or even California. When an Eastern Pacific storm approaches the Baja Peninsula or Mexican mainland or California for that matter, it weakens. The moisture doesn't just immediately disappear. It gets drawn northward into the monsoonal circulation. What starts as a tropical system off the coast of Jalisco may become a significant rainfall event in Tucson or Phoenix 2-3 days later. These moisture surges are responsible for some of the Southwest's most consequential rainfall events, and they happen more often in El Nino years. Let's continue moving westward across the tropical basins. That brings us to the Central Pacific, including Hawaii. The Central Pacific Basin sits between roughly 140 degrees west and the international dateline. NOAA issued a separate forecast for this basin on the same day as the Atlantic outlook, and it tells a completely different story. 70% chance of an above normal season. That calls for 5 to 13 tropical cyclones. For context, a normal season produces about 4 or 5 total. Most years, Hawaii sits in a relatively protected part of the Pacific. The surrounding waters are often just cool enough and the atmosphere environment just hostile enough that most systems weaken before reaching the islands. But El Nino kind of changes that equation. In El Nino years, tropical cyclone activity across the Pacific often shifts farther east. Storms forming in the eastern Pacific are more capable of surviving into the central Pacific basin, and the atmospheric setup near Hawaii can become more favorable for maintaining those organized systems. In 2015, half the central Pacific cyclones developed within that basin itself. That matters because it compresses warning lead times, or shortens those lead times. So a storm forming closer to the islands gives emergency managers and residents less time to prepare than one that's been tracked for days crossing the whole open Pacific. Let me continue by showing you what the rest of the globe looks like. And even if these storms never approach the U.S. coastline directly, global shipping, agriculture, energy markets absolutely feel the impacts of these active seasons across the globe. The Western Pacific is the world's most active tropical cyclone basin. In a typical year, that is. We already have a preview of what this season could look like. Super Typhoon Sinlaku in April was unusually intense. Scientifically, it was really a powerful storm, historically so in some cases. Now, the Tropical Storm Risk Seasonal Forecast, issued May 12th, calls for 27 named storms and 11 major typhoons. Activity running about 25% above the long-term average. And here's what matters for where those storms will eventually go, because El Nino shifts the monsoonal trough eastward, which tends to push formation zones farther out into the central Pacific. That changes the landfall geography in a specific way. Forecasts such as Guy Carpenter and Fudan University expect above normal landfalls in Japan and Korea, and below normal landfalls in the Philippines compared to a neutral year. So if you're in the Philippines, forecasts currently suggest somewhat lower landfall probabilities compared to a neutral year. If you're in Japan or Korea, probabilities suggest this is not a quiet season. The North Indian Ocean, specifically the Bay of Bengal, it can suppress these activities during peak El Nino conditions. Now, the Bay of Bengal historically produces some of the deadliest tropical cyclones on Earth. Mola, 1970, for example. Not because wind speed alone, but because of coastal geometry, shallow water, densely populated, low-lying coastline areas of Bangladesh and eastern India kind of amplify that storm surge far beyond what the wind speed alone would suggest. The suppression signal here is modest, a modest relief for one of the world's most vulnerable regions, one that includes much of South Asia. The South Indian Ocean and Australian region, El Nino typically suppresses cyclone activity near, say, northwestern Australia and shifts it, affecting more places like Madagascar, Mozambique, the Mascarene Islands, more so than the Australian coast. But the key point across all of this is that El Nino doesn't reduce the total energy available for tropical cyclone development globally. The sea surface temperature map right now shows anomalously hot water across essentially every major ocean basin. What El Nino does is redistribute, basically, where that energy organizes into named storms. The Atlantic gets quieter, Pacific gets louder, the Indian Ocean picture is kind of mixed by subbasins. So in a globally connected economy, which we obviously have, active Pacific seasons affect everything from shipping costs to agricultural markets to supply chain reliability, even for people thousands of miles away. Now there's one more piece I want to leave you with, and it applies to every basin we just covered. Rapid intensification. This is defined as a tropical cyclone increasing in sustained wind speed by at least 30 knots, or about 35 miles per hour, within a 24-hour period. When sea surface temperatures are anomalously warm, the fuel available to intensify these storms is elevated. Storms can go from a tropical storm to a major hurricane in, say, 36 to 48 hours. Hurricane Otis in 2023 demonstrated just how dangerous rapid intensification in the eastern Pacific can be. It exploded into a Category 5 hurricane just before landfall near Acapulco. The hard part about this rapid intensification is our ability to predict it. More than 24, 36 hours in advance, our skills remain somewhat limited in the extended ranges of those computer models, even with the improved models still. Now, within the modeling, we know the atmosphere is cooperating in one way, but in the more extreme cases, the modeling has less grip on extreme cases. So we have to be careful with this. We need to know in advance what actually arrives. And that's kind of the real risk, the real operational risk, where it lives between meteorology, the understanding of it, and how we simulate it using our computer models. 3 things to watch for this season. Number 1, Eastern Pacific named storm formation. When the first significant Eastern Pacific system develops, watch the track closely. Specifically, whether the associated moisture is being drawn northward, say toward the southwestern monsoon region, so Mexico, Baja, Arizona, New Mexico. NOAA's National Hurricane Center covers the eastern Pacific at the same site as the Atlantic, so good resource there for you. Number 2, the MJO, the Madden-Julian Oscillation, is the in-season signal, if you will, that modulates or changes tropical activity across the basins in a, say, 30 to 60-day cycle, give or take. Certain MJO phases actively enhance Eastern Pacific development. Others favor the Western Pacific or the Indian Ocean. The CPC Climate Prediction Center publishes a weekly MJO diagnostic. If you're interested, it's worth checking out if you're tracking any of these basins to a greater depth or further development of El Nino for that matter, which MJO also has an influence. Number 3, Atlantic sea surface temperature anomalies through July. Now, the Atlantic is running warmer than average right now. That warm baseline is one reason NOAA left a 35% near normal probability on the table. Ocean fuels, and if it's warm, we've got fuel there. Now, if these temperatures stay so warm throughout the entire season, the El Nino shear element, the strong winds aloft, may not fully do what it typically does. I'll be watching all of the major tropical basins throughout the season. When something shifts, something will shift, obviously, it is weather, I'll build a video around it. If this was useful, subscribe and share it with someone who's only seen the Atlantic headline, because the full picture matters. I'll see you in the next one.